Okay, people. All right, here we have another gas problem, another gas law problem. And what's our rule about gas laws? Well, let's see. What is the pressure in torr that a 0.44 gram sample of carbon dioxide gas will exert at a temperature of 46.2 Celsius when it occupies a volume of 5 liters? What's our rule about Celsius? We don't want Celsius, so we must convert them to kelvins. So temperature equals 46.2 plus 273. Okay, that's how we convert things to kelvins. And 46.2 plus 273 is 319.2 kelvins. Okay, so we're going to use kelvins. Next, we have some choices here. We could either use P1 over T1. We could use 22.4 liters per mole. Okay, or we could use PV equals nRT. Well, there's no place for grams in P1V1 over T1, the combined gas law, so we're not going to use that. In 22.4 liters, we have to have standard temperature and pressure in order to use that. Well, we don't have standard temperature and pressure, so we can't use that. So the only other thing we're going to use is the ideal gas law, which is Pivnert. Okay, so we begin plugging in our data. Pressure, we're looking for. We don't know it. Volume is 5.00 liters. Okay, 5.00 liters. N, moles. It says grams of carbon dioxide. We need moles to go in there. So how are we going to get moles? Well, I guess we need to go to the periodic table. Okay, and we need to figure out how many moles we have. So over here to the side, we're going to go find out how many we have. We have 0.44 grams of CO2, and we want to figure out how many moles. So 1 mole goes on top, and grams from the periodic table go on the bottom, and it's 44 grams from the periodic table. So we have 0.01 moles of CO2. Now our 0.01 moles will go into the equation. So let's go back. Let's put our 0.01 mole in here. Now what should we use for the letter R? Okay, so for the letter R, if we look in our textbook, we'll find that it has 62.4 millimeters of mercury in it. Well, millimeters of mercury are the same thing as torrs. So we get to use that number. So we get to use the number 62.4 millimeters of mercury, okay, liters over mole kelvins. And then our volume, or excuse me, our temperature is 319.2 kelvins. Kelvins cancel, moles cancel, all right, and then we're going to divide by both sides. Divide both sides by 5. So now liters cancel. Okay, so we have 0.01 times 62.4 times 319.2 equals that, divided by 5 will get us an answer of 39.83 millimeters of mercury. Well, geez, I thought we're supposed to have our answer in torr. Well, guess what? It's the same thing. 39.83 torr. They're the same thing as millimeters of mercury.